Okay, here we go. We've got another question about relative distances. And again, you'll notice we've got a relative speed of 0.8 c again. Love to see that again. Feel free to hit pause, try the question, and then press play. Okay, I always think these questions benefit from a slow read. Okay, we've got a fixed distance between the Earth and the star, which is dE. Okay, the spaceship is going to travel to the star at a constant speed, and the distance between the Earth and the star, as measured by the spaceship, is ds. Okay, now for this, we're looking at distances, and so therefore we're going to use our length contraction. Now, length contraction gives the relationship between L, the proper length, the observed length L, and proper length, and then gamma. Okay, in this case then, the proper length is the maximum distance, which is going to be attainable here by our the distance in this case between the two objects. Okay, so we're gonna look at the relationship between those. First thing we'll do is we'll calculate gamma. As I've said before, we've seen this 0.8 before. Hopefully, we've got gamma equal to 1 over the square root 1 minus v squared. We're going to ignore the c because they will cancel on both the top and bottom. We've got 0.8 squared, which gives me 0.64. We've got square root of 0.36, which is going to be 0.6, gives us a nice answer there of 5 over 3. Now, I've done that very, very quickly. You can feel free to take your time to calculate that. You'll find the answer there, 5 over 3. I'm going to immediately get rid of two answers here, which is B and C, because they have a 5 over 4. Okay, so we're looking always at ways of speeding things up. You know, you might be in a rush trying to make sure you get an answer correct. Well, 1 out of 2 is far better than 1 out of 4 chances, so that should work nicely. Now, the question is the answer 3 over 5 or 5 over 3? Now, when we think about observers moving, then they will tend to measure a shorter distance. Okay, this fixed distance is L0. Okay, in this case, the fixed distance is dE. So our observed distance measured from the reference frame of the spaceship is equal to the distance measured on Earth, because we don't move relative to it, divided by gamma. In other words, we're going to then find that ratio ds over dE. We'll just pull down the dE from the right-hand side, is equal to 1 over gamma, which is going to be 3 over 5, and therefore the answer here is A. In other words, the observers measure a shorter distance than the stationary observer.